Good afternoon and welcome to the Data Center. In our previous class, we considered Kruskawali's. This is it. And we use forest plots. Okay, so we started with the non-parametric, and then we imported our data set, Titanic data set, I said, which you can get on Argo or GitHub, and then we cleaned the data set. We then preprocess the data to convert the string data or feed into numeric using the label encoder, and then we started with the test. And we said for Pascal is used to test for differences between more than two variables. Okay. And the typical example is what we used on ANOVA, that is in parametric. So we will be running for non-parametric. So you load in your data set this way. This you can import this library, pandas, numpy, seaborn, and matplotlib. And then you can then clean the data set using the drop NA, and thereafter you process using label encoder. And we can then start with this. So let's start. Open your Jupyter notebook, and then we are using the start scip.stat as well. I will be importing. Let's change this. Let's change this to this is Mann Whitney. Whitney tests. Whitney tests. Okay. Okay. So for Whitney, it is Whitney U that the library is called. Whitney U. Whitney U. Okay. So we are getting that from the what's his name now? From the scip.stat library. This what we want basically is that we want the t value, the Whitney value, and the p value. Okay, so let's bring what we want. Survived. And then what again? Let's use papers. Let's see how it's entered by. Okay, so we can print now. We can print as f um, man u Whitney Whitney test. We have a p value. run this and see. All right, so you can see we have Mann Whitney tests, and then we have a p value that is 2.1 point. That is, it's also significant. That is 0.2 respectively, like that. So we said it is used for two variables. Let me add one and see what we're going to have. Let's add some adding sets to this. Let's run and see again. All right, so you see, we now have multiple value. Got this. This is the Mann hardening test. Then for the p-value, look at it. We have 2 points. This. So basically, it is used to compare between two variable, two categorical variable. Right. So we have a perfect result here. Okay. So let's use our rainforest, our code alongside there. Okay, so let's put this on our rainforest. Okay, so I will just copy this from the last class. I have the code here already. So from here, then I'll make adjustment to it. Let's see if we can use it for two groups. Oh my! All right, let's copy from here first. Let's copy. Okay, let's drag. Okay, so let's paste. Wow. Let's go back again. I've copied. Let's try. Okay, let's move again. Stop here. So I will then edit the code. Let's drag down. Okay, so let's edit the code now to fit in. This one was for three different variables. So we have for survive, we have for this. So let's remove this. Okay, let's remove this. And remove this. Okay, I want to compare. So then as this is okay, this line is okay. Let's come down. Okay, now for overall mean, I can use this. I've used sex and see. Okay, let me use sex for it this time. Okay, there is a well our reference point. Then this will have to change to my UWAP name. And U Whitening test. So let's PLT double. Okay, this one. Bravo! You see, we have a result, right? You see the Mann Whitening test above, and look at this. We have a survived first, then we have a P class here. So all put together exceed the comparison. They exceed the comparison. Look at this. this they exceed the comparison. You can see. So we are comparing the mean of suburban P class with the sex, that is the gender. So from this result, you can see that eggs they exceed this. However, from the comparison, there's a significant difference, statistically significant rather. Okay, and the Mann Whitney test here is 9,717. So that is that about Mann Whitney test. All right, finally, before we go to bed, we are going to look at a different normality test, and then we're testing using Kolromogrov, smirnov, to test for one sample whether it follow normal distribution with an existing data, okay, or I'm going to show you how to do that, or two sample, okay, with visual as well. All right, so we want to test for Kolromogrov using that same data set. Okay, so let's go ahead and import from the same site P. From the same site P, we import site P.start. We import kstest and num. Okay, let me add. Okay, so this I'll convert this now. I want to convert this to text. Okay, so this will be Kolromogrov, smirnov, smirnov, one sample test. So to do this, we'll be using a cumulative distribution and empirical distribution and a cumulative CDF. Using the two, I should check and see if they are very close. They are very close, then we said okay, the data follows a normal distribution. And if they are far, the result, the k value will tell us the quantity, the magnitude of the distance between our sample and the already established sample distribution. Okay, so and that is why from this we are importing this library kstest, that is Kolromogrov smirnov test and num. Okay, so be importing this. Now let's go ahead and do this. Data is equals to df and then the reference point here survived. Okay, and then we'll close. So that is the data we are making reference to here. So to do this again, we need to also sort data out. We need to sort it and then go ahead with other things. Okay, but before the sorting, let's quickly work on this. Because we need the sorting for our chart. So run this, we need this. Okay, so this is it, k starts and the p value. So bring in this library knest and then the data, look at it here, num, look at this num, and then in this argument you see we are looking for the mean and the standard deviation. Look at the two methods. So we can print f Kolromogrov smirnov smirnov test. And we have key stats. And we have the p-value. Then we have the p value. Let's close this. Okay, let's print and see. We have an issue somewhere. Okay, yeah, there's an issue here. Let's check. Let's okay, we have this. Okay, let's remove this. Let's remove this. Let's run again. See. Okay, bravo. We have our result. We have an issue. Okay, start p start. Okay, so let's correct. So let's check this issue somewhere. Okay, let's try again. Let's run up there again. Now from here. Okay. Let's move this. Okay, so we have our Kolromogrov minus test with this. Then we have our p-value to be this. Okay. So what we are left with now is running for plotting our chart. Okay. So we are going to use the CDF and then the PDF. Okay. So now we have to now make use of our NumPy library that we imported when we started this class. Look at it, NumPy as NP. So we use NumPy for sorting, for arrange, respectively. So let's come here and bring it in. So not this. Okay, so they are naming the data sorted np.sort. Then there's numpy sort this data here. Okay, so we are sorting the data. The next thing is we are going to arrange the and to arrange data. We're also using our numpy. Okay, this time around we are saying cdf empirical is equals to np.arrange, then starting from 1, len data sorted plus 1. That is, because you continue from this one, the next one will be 2, the next one will be 3, 4, 5, 6, 7, 8. So in arithmetic progression divided by the data sorted. Okay. What we do now is to generate data, a reference data in which you are going to compare this with. So generating reference CDF value from the normal distribution. Okay, from this we want to generate, and to do that, that is where this norm comes in. So CDF theoretical equals to norm, this norm here, dot CDF. Then what are we making use of? The data sorted here, the location, data dot the mean, the scale, we're using data dot standard deviation for our scale. The next thing is to plot. So on our figure, that is 8 on the x-axis and y, and 6, the length of 6 on the y-axis, this x, y. Okay, then what are we plotting? The first thing we are plotting is our CDF empirical, this, and the second one is CDF theoretical. All right, for the empirical, we are using our marker, just dash and then the line style this time around none. We don't, unlike the other when we did rainforest and we used line dash line. Okay, so and there's no line style, so we're using a default line style. And then the label, we're labeling this as empirical CDF. And then the second plot, data sorted as well, but this time around the value we generated, okay, that we're making reference to, that is CDF theoretical, then we are labeling this theoretical CDF normal. Okay, that is a normal distribution that we're comparing, that is as our reference point rather, and this will be marked with color red. Okay, the next thing we are going to do is to add label, the S label, Y label, and the title. So for the title, we are using empirical CDF versus theoretical CDF. Then the S label, we're using survived. Okay, then next thing is PLT dot using grid. So before we go, we are going to have our two sample Kolromogrov sign up test. Okay, okay, two sample. Okay, let's go. We're going to have this group one equals to df survived, group two equals to df sex. Okay, so we have this these two groups, so we can run for our test now, and just scroll up, scroll up, scroll up. You can pick this. Let's go. I'll pick this. Let's go. And then correct that one. Okay, okay. Now we need this, but this is what we are using. This. Okay. Okay. So now what we are printing now is group one, group two. Prints. Kolromogrov test. KS stats p value. Okay, I have a p value. Let's run this and see. All right, we have these two significant. All right, so the next thing we're doing is plotting these on our charts, just like the other one we did. The next thing to do is to sort our data using the numpy. All right, so group one sorted, we have to sort. Group two sort using np. The next thing is to arrange using the same numpy. Okay, so we have the CDF group, arrange one, then group one sorted plus one follow. Same thing this. Okay, next thing is to plot. So to plot, so the same size on the x-axis 8, y 6, that is in length. Then you plot group 1 sorted, stated here. Then the CDF group 1, look at it here. CDF group 1, the marker, this is it, line style none, line style none. Okay, the label, all right, we use survived CDF, and then color blue. The other one, the color is red. Okay, so the next thing is to then label. Okay, next thing is to add label. Okay, so we have this, the on that is title. We have CDF comparison, that is two sample Kolromogrov smirnov test. Then the X we have data values. Then we have PLT, that's Y label, we have the cumulative. Then we have legend. Then to show, that is show plots, PLT dot grid. We have this to be true. We want it to show our grid line. PLT dot show. All right, let's run and see. Bravo. All right, so you can see that it's only one of these that follows the order, that is this gen. Look at, okay, for blue color is survive, the red color is the sex. So for survive, it's just one of it that follows each other. All right, the other one we are not seeing, it maybe it is subsumed in it. So you can see that the data follows a normal distribution. All right, so this is for two sample. All right, we're going to stop here today. Look at the one sample. We have this, okay? So in our next class, we are going to look at Shapiro week. Shapiro week, and I guess that will be the end of the statistical analysis class. Subsequent class will then be on machine learning. All right, thank you for listening. If you've not subscribed, please do well to subscribe.